You can create mathematically derived forms in SketchUp with Ruby scripts, and I'll show you 3 separate scripts that I've used from time to time. First of all, Peter Brown has written a script called Draw Helix, which is invaluable when you're creating handrails for circular stairs, screw threads, or any number of helical structures. Gavin Kistner has written a geodesic script, which I'll demonstrate in a moment. And finally, Claudius Crutch has written K-tools, which allow you to graph equations in SketchUp. We'll take a look at Draw Helix first. It's on the Draw menu, and it has a dialog box. You'll see these approximate measurements in here because it was written in metric, and so it's converting automatically here to these imperial units. I'll type in 4 feet for both end and start radii. The pitch is the height of the helix. I'll make that 3 feet. I'll set 5 rotations with 24 segments per rotation. And there's the helix. It creates a polyline. Let's try it again. Draw helix. This time, the end radius will be 0, and I'll start with a 4-foot radius and a 3-foot pitch. In this way, you can make the helix diminish. Gavin Kistner's script is on the Plugins menu at the top of the list. Create Geodesic. The first thing we're asked here is to select a primitive type. Looking at this list, I'm wondering why we don't see cube or dodecahedron. After I used the tool, I realized that these aren't actually the primitives that you're generating. These refer to the internal structure within the geodesic dome. I'll use an icosahedron for the internal structure, and I'll set the radius here. Note that you can't use feet here. It has to be in inches. So if I want 12 feet, I'll have to type 144. I'll take that with 2 subdivisions and click OK. We have an instant buckyball. Let's try that again with a different type of internal structure. I'll go back to the Plugins menu and choose 144 for the radius, and this time we'll go with tetrahedron. We get a different type of structure, not as conducive to making a dome. The last script that I'll just touch on are the K-tools. They're also located in the Plugins menu. There are many different graph types that you can create here. Let's just take a look at the 2D graph in Cartesian coordinates. We'll create a graph in the XY plane, in other words, the red-green plane. I'll accept the default values for the range and the step width. And here we can type in a mathematical formula. This is x to the second power, or x squared. This is the equation for a parabola. Let's take a look at it in the top view. I'll make another graph in Cartesian coordinate space, also in the red-green plane, using the default range and resolution. This time I'm going to type in a formula that I looked up in Wikipedia for a catenary curve. It's the hyperbolic cosine of 1.6 times x. This represents the curve that you get when you hang a length of chain or cable under the influence of gravity. If you turn this upside down, you would create a self-supporting catenary arch that doesn't require buttressing. So the mathematical tools can be useful for creating real objects.